Hello, hi everyone. Welcome to the Student Brand. This is your Siva sir. Today topic is human and colorful world. Human and colorful world. Okay. So now we'll discuss human and colorful world. Human and colorful world. So human and colorful world. Now human eye is the most sensitive and sensible organ in our body. Okay. So by closing your eyes, if you close your eyes, you can't able to see anything. Once you open your eyes, you can see everything. Okay. Uh, because of the eyes only, we can able to see everything in front of us. Today we will discuss about eye parts and function. Eye parts and function will discuss. Okay. And now I am drawing the eye diagram. So I can draw. Observe. Okay. So this is about human eye. Hi everyone. Welcome to the class. So I'm taking now. So front portion is called cornea. Front portion is cornea. Ciliary muscles. Ciliary muscles. This also ciliary muscles. Ciliary muscles. Okay, iris. Here also iris. This is iris. And I am considering here aqueous humor. Aqueous humor. And next one, vitreous humor. Vitreous humor. This is retina. Retina. And this one, optic nerve. Optic nerve. This is the optic nerve. Optic nerve. And here a blind spot is there. We will discuss about this eye parts and function now. Eye parts and function. So now you can observe here. Okay. First one is the cornea. Cornea is the frontal layer, protective layer of the eye. Most of the refraction takes place at the cornea. Frontal layer, protective layer of the eye. Most of the refraction takes place at cornea. And ciliary muscles. Ciliary muscles are the okay. So ciliary muscles will hold the lens. It will adjust the curvature of the eye lens. Whenever we want to see the nearby object, far by object, nearby object as well as far by object, ciliary muscles will adjust the curvature of the eye lens, so that we can able to see the nearby object as well as far by object. So when you are seeing the nearby object, eye lens become thick, eye lens become thin, so eye lens become thick, eye lens become thick, focal length decreases. So when you are seeing the nearby object, eye lens become thick, focal length decreases, so that we can able to see near distance object. When you are seeing the far distance object, eye lens become thin, focal length increases, so that so here you can see, when you are seeing the far distance object, when you are seeing the far distance object, eye lens become thin, focal length increases, so that focal length increases, we can able to see far distance object. We can see far distance object. Once again, when we want to see the nearby object, when we are seeing the nearby object, eye lens become thick, so that focal length decreases, we can able to see the nearby object. And so when you are seeing the far distance object, eye lens become thin, focal length increases, so that we can able to see far distance object, right? So with the help of ciliary muscles only, we can able to see the nearby object as well as far distance object. So what is the near distance object? Near distance object is nothing but near distance near point. Actually near point, if you are considering, near point is nothing but the minimum distance up to which a person can able to see clearly without any strain. The minimum distance up to which a person can able to see clearly without any strain is called a near point. Far point is nothing but the maximum distance up to which a person can able to see clearly, a maximum point. Far point. The maximum point up to which a person can able to see clearly without any strain is called far point. Near point is nothing but the minimum distance up to which a person can able to see clearly without any strain, that is called near point. That is 25 centimeter. Coming to the far point, far point is infinity. The maximum distance up to which the maximum distance up the maximum distance up to which the maximum distance up to which okay, near point is minimum distance up to which a person can able to see clearly without any strain is called near point. Maximum distance far point is nothing but the maximum distance up to which a person can able to see clearly without any strain, that is called far point. So the far point is infinity. For a healthy person, for normal person, these are the values. Near point is 25 centimeter, far point is infinity. So now, yeah, thank you so much, NK Movies. Thank you so much. So, thank you for watching my old videos. Definitely, I will do my level best to teach. And here, so those are the ciliary muscles. Asta Singh, okay. Teacher Aman Kumar. Okay, NK Movies, try to contact the number. So my number is there in old movies. Old videos. My number is there. You can contact to me. I will discuss. NK Movies. So just try to see the number. You can WhatsApp me. WhatsApp me. WhatsApp is working now. So you can send a WhatsApp message. Now it is there with me right now. It is there with me. You can send a message. I will reach to you. Is it okay? So check my number. You can send a WhatsApp. NK Movies. You can send a WhatsApp. We will discuss. WhatsApp is available on this number. Okay, so come to the point. Okay, done. Then you can contact to me. So through I will share my Instagram link. So I'll be sharing the Instagram link. Check once. So I pinned the Instagram. So students, you can join to that link. Thank you so much. Okay, so come to the point now. Aqueous humor is a jelly type liquid present between the aqueous humor is a jelly type liquid present between cornea and eyelids. Aqueous humor is a jelly type liquid present between cornea and eyelids. So it provides a sufficient blood and nutrition to the central cornea. Okay, next one we can go for iris. Iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm which controls the size of the pupil. Iris, so this is the iris. Iris is a dark muscular diaphragm which controls the size of the pupil. Size of the pupil. Okay, and so people will control and regulate the amount of light entering into the eye. People will control and regulate the people People will control and regulate the amount of light entering into the eye. So the gap is called pupil. This gap is called pupil. People will control the amount of light entering into the eye. Okay, people will control and regulate. Control and regulate the amount of light entering into the eye. So iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm. So which controls the size of the pupil. Which controls the size of the pupil. People will control and regulate the amount of light entering into the eye. Okay, and coming to the vitreous humor, this entire portion is filled with the vitreous humor. Islands to retina, islands to retina. This entire portion is filled with vitreous humor. It is a jelly type liquid present. It is a jelly type liquid present between islands and retina. Islands and retina. Okay, it provides the sufficient force and pressure to maintain that shape. To maintain that shape. Okay, and the retina is a okay. Okay, sure. So that is the email ID. Hi, Prish Dash. Okay, I'll continue. Yes. Now you can see here. So vitreous humor, retina, optic nerve. Vitreous humor, retina, optic nerve. So retina is a light sensitive screen. Retina is a light sensitive screen. Retina is a light sensitive screen. Light sensitive screen. So there are two types of light sensitive cells are there. Wow. Those are one is rod. Those are one is rods. Another one is cones. Cones. Okay, rods and cones. Rods help the intensity of the light. Rods help the intensity of the light. Cones help the color of the light. Rods help the intensity of the light. Cones help the color of the light. Okay. Rod helps the intensity of the light. Cones helps the color of the light. So in the mail will no. So remaining all details will discuss. So try to cooperate because class is going on, right? So I'm taking class. After the class, we will let you know. Okay, we will discuss remaining things. Okay, so retina is nothing but so it is a light sensitive screen, light sensitive screen. So there are two types of light sensitive cells are there, rods and cones. Rods helps the intensity of the light, cones helps the color of the light. Rods help the intensity of the light, cone helps the color of the light. Optic nerve is nothing but. So whatever the image is forming at retina, that will convert into electrical signals that will pass to the brain through optic nerve. Okay, so that is about retina and optic nerve also. So this is about human eye. Okay, human eye. Human eye. So once again, cornea is the front layer, protective layer of the eye. Most of the refraction takes place at this part. So ciliary muscles will adjust. Ciliary muscles will adjust the curvature of the eye lens. Okay. So next one, eye lens. Eye lens is the crystalline lens. Eye lens is the crystalline lens. Eye lens is the crystalline lens. Crystalline lens. Eye lens is the crystalline lens. Crystalline lens or eye lens, or simply we can say convex lens. Convex lens. Okay. Here, eye lens is whenever the light ray falls on it, it will converge the light rays and make it falls at retina. And aqueous humor is a jelly type liquid present between cornea and eye lens. Aqueous humor is a jelly type liquid present between cornea and eye lens. Cornea, eye lens. Okay. So cornea, and coming to the iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm which controls the size of the pupil. Pupil will control the People will control and regulate the amount of light entering into the eye. People, so this the people. People will control and regulate the amount of light entering into the eye. So eye lens is the crystalline lens. Crystalline lens. Okay, so when the light ray falls on it, converge and make it falls at retina. Ciliary muscles. Ciliary muscles. I am taking ciliary muscles. Okay, ciliary muscles. Ciliary muscles. Next one, retina. Retina rods and cones. I am saying rods and cones. Okay, so retina is the light sensitive screen. So there are two types of rods and cones are there. Those are light sensitive cells. So rod helps the intensity of the light, cone helps the color of the light, and the ectosimmer is a jelly type liquid present between eye lens and retina. Eye lens and retina. So this entire portion is filled by the vitreous humor. Vitreous humor, it gives the sufficient force and pressure to maintain that shape. Optic nerve, what are the images forming at retina that will convert into electrical signal that will pass to the brain through optic nerve. Okay, so this is about human eye and parts and function. Next one, we'll discuss about power of accommodation, the ability of the eyelids to adjust its focal length. The ability of the eyelids to adjust its focal length is called power of accommodation. The ability of the eyelids to adjust its focal length is called power of accommodation. Power of accommodation. The ability of the eyelids to adjust focal length. Okay, now we'll discuss about power of accommodation. Ability of the eyelids to adjust its focal length. Ability of the eyelids to adjust its focal length is called power of accommodation. So, in that, when you are seeing the nearby object, near point is 25 centimeter, far point is infinity. Near point is 25 centimeter, far point is infinity. So the range of vision is 25 to infinity, 25 to infinity, 25 to infinity, right? And coming to refractive defects. So there are three are there, three refractive defects are there. One is myopia, hypermetropia, presbyopia. Myopia, hypermetropia, presbyopia. Okay. So what is myopia? Myopia is nothing but the person can able to see near distance. He can't able to see the far distance. The person can able to see the near distance. He can't able to see the far distance. That is called myopia. Myopia, by using of concave lens, we can correct the defect of myopia. By using concave lens, we can correct the defect of myopia. So I'll draw the diagram. Here you can see. I'm taking this one. So 25 centimeter, and this is infinity. 25 centimeter and infinity. 25 centimeter and infinity. Okay. So the person can able to see clearly near point, that is 25 centimeter. He can't see the far point. But somewhere in between 25 to infinity, he can see that the far point of myopic eye. Far point of myopic eye. Far point of myopic eye. If the light rays are coming from this point, you can able to see. So this is near point and this is the far point. The person can able to see clearly at objects are placed at 25 centimeter up to a certain limit, that is far point. Until this one he can see. Beyond the point, so infinity he can't see, infinity he can't see, infinity point he can't see. For the correction of that, so we are using concave lens, we are using concave lens. So how to draw the diagram? See this diagram anyway, so this point anyway we can see. Okay, so no problem. If the light rays are coming from this point also we can see. But this point we can't able to see. So how it will be, where it will form, and we have to correct this defect. So those three diagrams if you draw, that's enough. Once again, so far point of myopic eye, far point of myopic eye and infinity and a correction of that point. So that's enough. Now I will draw the diagram. Now I will draw the diagram. Check once. Right. So I'm considering. I'm taking the diagram. Drawing the diagram and check it. So light rays, as I said, light rays are coming from far point. You can able to see. Light rays are coming from far point. You can able to see. Now I am taking here. Light rays are coming from this point. So if the light rays are coming from infinity, where those light rays will meet, we will see where the light rays will meet. So I'm taking the light rays here. Light rays are coming from infinity. Okay, these dotted lines represent light rays are coming from infinity. Okay, that is a far point of myopic eye. F is far point of myopic eye. So this light rays, we can't take from one point. We can't take one point. So we have to take dotted lines. Those are coming from infinity. Okay. So now, so what lens will use to correct the defect of myopia? We are using concave lens. Concave lens. Concave lens to correct the defect of so I am considering here near point and this the far point. Light rays are coming parallel to the concave lens. So here, so those will be converge. Again the light ray will converge and meet at retina. Here, the light rays are meeting. If you are extending, so those will meet at a far point here. Okay. So this is a correction of yes. Now this is the far point of far point of myopic eye. Far point of myopic eye. Myopic eye. This is the myopic eye. This diagram is myopic eye. Myopic eye. Myopic eye. And this one is the correction of myopia. Correction of myopia. Correction of myopia. Correction of myopia. One check it. So in the second diagram, by seeing the second diagram, we can understand. In the second diagram, you can observe. By seeing the second diagram, you'll get to know the. By seeing the second diagram, you'll get to know the causes. Eyeball become too large. Focal length is less. Focal length is less. Eyeball is too long. So those are the defects. Those are the defects. Defects are here. Eyeball is too long. Focal length is too small. Right? So this is about so second by seeing the second diagram, you'll get to know the causes. You'll get to know the causes. Okay. Next one, hypermetropia. We are going to discuss about hypermetropia. Hypermetropia. Hypermetropia nothing but, so the person can able to see clearly far distance. These are all refracted defects. These are all refracted defects. So this are 25 centimeter and this the infinity. The person can able to see clearly far point. Infinity he can see, but near point he can't see. So infinity he can see, but near point he can't see. But somewhere between infinity 25 centimeter he can see. That is the near point of hypermetropic eye. Near point of hypermetropic eye. Near point of hypermetropic eye. So now we'll draw the diagram how to correct and what is the defect. So now you can observe. First, you have to draw this one. Okay, near point of hypermetropic eye. If the light rays are coming from near point, because he can see right, infinity he can see. So he can see this point also, but he can't see 25 centimeter. 25 centimeter he can't see, right? So now we will discuss about this point where light rays are coming. Where if the light rays are coming from 25 centimeter, where those light rays will meet, we will see. And this one, if the light rays are coming from near n dash, where it will meet. So we'll start. So now we'll see. Mhm. Yes, convex lens is for correction. Okay. So now you can see this is the near point of hypermetropic eye. Near point of hypermetropic eye. This is hypermetropic eye. This one is hypermetropic eye. This one is the correction of hypermetropia. Correction of hypermetropia. Okay. If the light rays are coming from this point, near point, you can see. If the light rays are coming from N, so 25 centimeter, you can't see light rays will meet beyond retina. So here, if you are taking convex lens, by using convex lens, we can correct the defect of hypermetropia or a hypermetropic eye also we can write. Hypermetropic eye. Okay. Hypermetropic eye also we can write. Hypermetropic eye. Done? That's enough. So this is about, these are the refractive defects. Refractive defects, myopia, hypermetropia, hypermetropia, presbyopia is nothing but the person can't able to see near distance as well as far distance. So presbyopia is nothing but the person can't able to see near distance as well as far distance. For the correction of presbyopia, we are using a focal lens. Upper portion is concave lens, lower portion is convex lens. So this is about refractive defects. Okay. So next one. This is about eye parts and function. Eye parts and function. So we'll discuss about colorful phenomena in the next class. So thank you so much for joining, and do like, share and subscribe to Student the Brand. If you like the content, if you like my explanation, you can do like, share and subscribe to Student the Brand. This is Vasavasa from Student the Brand. Thank you so much. So my Instagram page is there. So I pinned it. Just check once. Thank you so much. We'll see you in the next class.